Hello, I'm Todd Spatafor, and this is another spectacular thing. About 4 years ago, I built a NAS out of a Raspberry Pi 4 and 4 spinning Rust hard drives in a nice case. This one. This is the Argon Eon case. Since then, I've had quite a few people reach out to me and ask me questions. And recently I got a fantastic email from a viewer, and honestly, I think a lot of you have the same questions, just based on the feedback that I've received over the past 4 years. The question is, do I need to build a file system on each of the hard drives before creating the RAID? It's a very good question, very good teaching moment, so I'm going to take this opportunity to explain why you do not need to build a file system on each of the drives. By the end of the video, I believe you'll have that aha moment about RAID, so that RAID finally clicks with you. And if not, leave comments and we'll see what we can do. So here's the issue. When you think about setting up storage, your brain goes to this pattern: drive, partition, file system, mount point. But with RAID, the mental model is completely different. It's drive, partition, then stop. Do the drive partition step on all 4 drives, or however many drives you have. Then you combine that into a RAID array, dev/md0, and then you put a file system on that array. And then you mount that file system that's on the array. Now, this is very important because you don't want to have a file, or each individual drive does not have a file system on it. If you think about it, you're not setting up 4 drives. Well, in this scenario, we're not building 4 drives. We're building one array, one RAID array. The RAID device, dev/md0, is what you treat like a normal disk, not dev/SDA, SDB, SDC, SDD, etc. It's that dev SD or MD0 that you treat like a disk. So why do AIs or generic tutorials lead you astray in this scenario? It's because those are trying to get you to build individual drives, not a RAID array. Again, RAID array, you stop much earlier in the process. You don't format the drive. Okay, enough of that. What do you actually need for RAID 5? What do you actually need for RAID 5? Do you need a file system on each SSD? No. Again, no, you don't. Do I need mount points for each drive? Again, no. You mount just the RAID array. And the third question is, how far do I go in this process? I think you all understand where to stop in this process now. You can either, option A, now I will make a change here. Option A is you can use the whole disk and skip partitioning altogether. You'd do mdadm -- create - drives, and you'd do that whole thing. And then instead of dev/sda1, you do dev/sda and then dev/sdb and dev/sdc, etc. Directly in mdadm. The option B, which is what I've been choosing, and it's more flexible and I think it's recommended, would be to run fdisk on each disk, create a partition on that disk that fills the whole drive. So you'd have SDA1, SDB1, SDC1, SDD1, etc. if you have more disks. And then you'd set the partition to Linux RAID, which is type FD, I think, if my memory serves me. And then you stop there. You don't make file system and you don't mount it. So between the two, you stop before you create a file system on it. So let's look at the correct workflow, shall we? So let's step through this. The first step is to identify your drives. To do that, you do lsblk to identify your drives. Here we have SDA1, or SDA, SDB, SDC, and SDD. They all have a partition on them, but we're going to delete that in the next step. So then you would want to partition each drive. To do that, you use sudo fdisk and then the drive /dev/sda or NVMe 0 and 1 if you want to use NVMe drives. Inside fdisks, you want to first delete any partition, so D, and then you want to create a new partition, so that's N. You want that to be a primary partition, partition number 1. I think those are the defaults, so you can just hit enter a couple times. Enter for the default first sector and enter for the last sector. That would use the whole drive. Oh, if you want to use whole disks, you skip this step. But I usually partition my drives. I don't think it hurts either way. But again, if you know of a reason why you would want to use a whole disk versus a partition disk, let me know in the comments. Next, you want to create the RAID array. So that's sudo mdadm --create /dev/md0 --level 5. We're doing RAID 5 in this example. --RAID devices equals 4, because I have 4 disks, and then you list out the disks after that, as you can see in this command. You'll see a warning. It's asking if you're sure that you want to create an RAID array, and of course in this scenario you do. This is going to destroy any data on the disks, so be sure to have a good backup, or if they're brand new disks, who cares. Type Y to confirm. And then step 4, this is important. You got to watch the RAID array, because it actually builds the RAID array. So you could do cat/proc/mdstat, cat/proc/mdstat, or you can watch cat/proc/mdstat, which I do. This takes a while. This takes hours. For my 2 terabyte drives, 4 times 2 terabyte drives, this took 8 hours. But watch it carefully. You can see in my example here that the algorithm, it says algorithm 2 bracket 3/4 and then bracket UUU underscore bracket. That's because one of the drives is being rebuilt. And I have this all the time on these disks, and that's because I think one of the disks is going bad, but that's just for an example for this video. Okay, so what next? Technically you can use the drive, the array, before it rebuilds, but you could lose data if you don't let it settle first. Next step, step 5, you want to create the file system. Now I do ext4 because that's what I'm used to. You can use Btrfs if you want to, or other file systems if you need to. Sudo makefs.ext4/dev/md0 is your command. You can also label it if you want. I'm not going to label it. And please note, again, we're doing makefs on /dev/md0, not dev/sda1, sdb1, stc1, and std1. We're only doing it on dev/md0. That is the critical difference, okay? We're creating one file system on one RAID array. Okay, so let's create a mount point. So sudo makedir-p/m and t for mount /raid. Then you sudo mount dev/md0 to /mount raid. And then you verify it worked with df-h, and everything should be good. You can see here on this example that we have dev/md0 with 5.5 terabytes, and it's mounted on /mount raid. You'll see that we have 5.5 terabytes even though we have 4 2 terabyte drives. 4 2 terabyte drives is 8 terabytes, and then you lose one whole drive for parity. One whole drive's worth for parity. Parity's spread across all 4 disks. So that would be 6 terabytes. And then just because this is terabytes versus terabits, is that how you pronounce it? TIBs. that's not how you pronounce it, let me know in the comments. I don't care. Um, and then that would be 5.5 terabytes in total. So you can make it permanent with fstab. You'd want to unmount the /mount/raid. You'd want to do sudo block ID on the md0 drive, and that'll give you the UUID that you'd want to put in fstab, like this. You need to save the RAID configuration. It is important for surviving reboots. Sudo mdadm --detail --scan and pipe that into sudo tee -a /etc mdadm /mdadm.conf, and then you want to update the init ramfs. You'd want to, so that the RAID starts on boot. So sudo update init ramfs -u, and that tells the system about your RAID array, and then you're good to go. I think that's it. You can go through the old steps for verifying that everything is correct. With df-h, you mount it. You can mount grep md0 and it'll list just that mount point. And if you're successful, run lsblk, and there you'll see SDA, SDA1, MD0, and then you'll see SDB, SDB1, MD0, and you'll see the mount point is /mount/raid, and you're good to go. Of course, you'll see 4 of those, or however many drives you have. And let's see. Okay, common pitfalls. Creating file system on individual drives. You don't want to do this. You just wiped out any RAID metadata that might have been on that partition. The drive is now configured as an independent ext4 file system, and it cannot be used in a RAID array without reformatting. How to fix it? You need to start over with that drive. So you start over with the fdisk utility. You delete any partitions on there. You recreate the partition. You leave it blank. You set the partition type to FD, and you're good to go. Mounting individual drives in fstab. Again, you don't want to mount each individual drive. You want to mount the one RAID array. If you did that, you want to remove those lines from your fstab, if that's what you did. You want to add the RAID device in fstab. Using drive letters instead of UUIDs. So in fstab, you can use /dev/md0 in the first parameter instead of the UUID. That's possible, but if you added a second drive, md0 might become md1. So you don't want to do that. Use UUIDs instead, because they never change. What else? What else do we have? Saving mdadm configuration. You create the RAID array and it works. You reboot and the array doesn't reassemble, or worse, it does reassemble, but it has to rebuild that last drive. Linux doesn't automatically remember RAID configurations. You must save it to /etc/mdadm/mdadm.conf. I'm getting sick of saying mdadm. And last but not least, interrupting the initial sync. Do not power off. So when you're doing, right after you create the build, the array, it has to build that parity information. So don't power off the initial RAID sync. Do not power off during the initial RAID sync. Do not remove drives during that sync, because you'll lose data. The array is in a vulnerable state during that initial sync, and interruption can cause data loss or array corruption. If you must stop it, wait for the sync to complete to at least 50%, and check the proc MD stat before any power operations. Let's look at troubleshooting. Okay, again, I'm reading off my notes, so sorry, mdadm device or resource busy, you're trying to create a RAID array, but you get this error message. Causes the partition is already part of another RAID array, the partition is mounted, or the partition has an existing file system that's auto-detected. So solutions for that are: check if the partition is part of an existing array using cat/proc mdstat. 2, check if it's mounted. That's mount, pipe that to grep SDA1, for example, 1, 80, A, B, C, D, whatever. Unmount if needed, and then remove any existing RAID superblocks. And I do this quite often to remove the RAID superblocks. So here's the command. Oops. Here's the command. Sudo mdadm --0 superblock/dev/sda1 or sdb1 or stc1 or whatever. And then try creating the array again. If you need to start over, how to safely remove the RAID. If you messed up and you need to completely restart fresh, follow these steps. Sudo unmount mount RAID, and then sudo mdadm stop dev0. You want to 0 the superblock for all of the drives, and then you want to remove from the mdadm.conf, remove the line about md0. You'll add that in when you recreate the build next. Then you can start fresh with mdadm-create. Okay, issue 3. Drives show up as SDA versus dev disk by ID. So the question is, should I use dev SDA1 or dev disk by ID XXX-part1? And the answer is either works for creating the array, but dev disk by ID is more stable across reboots. If you swap a drive, dev SDA might point to a different physical drive. Using by ID ensures you're always referencing the right physical disk. And so you can use a command that looks like this, and this will build the array by IDs instead of by drive letters. Okay, array shows inactive after reboot. RAID array doesn't auto-assemble after reboot. Proc mdstat shows array as inactive or doesn't show at all. The cause of that is mdadm configuration not saved or not loaded during boot. The fix is to assemble, do sudo mdadm -assemble like this, or then save the configuration properly. Sudo mdadm -detail -scan, pipe that to sudo ta -a, like this. And then you want to update the initial RAM file system. Okay, one drive failed. What do I do now? Oh no, a drive failed. Well, that's the whole point of RAID, isn't it? Is if a drive failed, you want to remove that drive, and then you want to put a new drive in and rebuild it with these commands here. Okay, so let's recap. Remember, individual drives get partitions, not file systems or mount points. Okay? The RAID array becomes your single logical drive. That gets the file system. Use UUIDs in your FS tab, save your mdadm configuration, and let the initial sync finish. That could take 8 hours or more. Big thanks to the viewer for sending in these questions. I won't name them because they found their solution before I could make this video. This is exactly the kind of confusion that helps me create better content. So I want to thank you very much for your questions. Please, if you have any other questions, leave them down in the discussion below this video. And the next video in this series is actually what do we use this? We've got this great RAID array now. What do we use it for? And I'm going to use it for a media backup station. And so in my next video, I'm going to build a media backup station. Thank you for watching. And if this helped you, please click the like button. If you found that it didn't help you, click the dislike button twice. But seriously, drop me comments below and hit subscribe. So thank you for watching. This has been another Spectacular Thing. Bye.